You don't think about it, but everything you use, your phone, your car, a jam jar on your shelf, had to be built to fit, not just approximately, but exactly. This fit has a name, tolerance, and the tighter the fit, the higher the cost. In today's story, we're going to find out why trying to get it just right in manufacturing costs so much, and what cutting-edge engineers are trying to do about it. Imagine placing this jam jar between two books. The shelf is 10 centimeters wide, your jar is 9.8 centimeters wide. That's 0.2 centimeters, that's tolerance. The wiggle room allowed between what's designed and what's made. In machining, we give these margins names: unilateral, bilateral, limit tolerance, and when things get complex like aerospace parts, we use something called GD&T. It's like grammar for engineers, defining not just size, but shape, orientation, and even how round a hole is. When tolerances are too loose, things rattle, gears slip, engines fail, but when they are too tight, you waste time, you scrap parts, you overpay. It's the ultimate design tightrope, cost versus precision. Here's where it gets painful. You want to fit within 0.01 millimeters. That means newer tools, slower cuts, more inspections, and often more waste. One study showed that 70% of manufacturers consider tolerance the number one cost factor, and it's worse for small parts or tough materials like titanium. Remember that jam jar we spoke about? Now imagine needing to fit 1,000 jars onto 1,000 shelves, all exactly right. One off, the whole cabin fails. So how do engineers deal with this? They optimize. In a recent study, engineers looked at two real-world assemblies, a piston cylinder and a punch die. Their goal: minimize total cost, not just machining cost but also quality loss. They use cutting-edge algorithms like PSO, particle swarm optimization, inspired by Bayes flocking, and NSGA2, a genetic algorithm that evolves the best solutions. The results: for just machining cost, PSO wins. For total cost, including quality, NSGA2 performs better. These ain't just academic tools anymore. They are now part of the digital manufacturing ecosystem. Here's something few people tell you in engineering school. The time to think about tolerance isn't during machining, it's during design. Because if you don't define tolerances early, manufacturers will guess. And their guess might be too loose or too tight, and that means risk or cost, even both. Not everything needs 0.01 millimeter precision, but when it does, it really does. Industries like aerospace, defense, and medicine live and die by tolerances. If that gear doesn't mesh or that bone screw doesn't fit, the consequences can be catastrophic. But here's another truth: over-specifying tolerances is one of the fastest ways to burn money. If the part isn't critical, don't demand critical precision. Save the perfect bookshelf alignment for the structural parts. Let the decorative trim flex a little bit. That jam jar on a shelf is not just a household image. It's a metaphor for the entire world of manufacturing. When done right, it fits perfectly. When done wrong, the whole structure falls apart. Tolerance is not just about numbers. It's about knowing when to care and when not to. Precision is expensive, but only when you ask for it everywhere. Next time you design a part, ask yourself, is this a jam jar or just the shelf it sits on? If you enjoy this type of deep dive, hit that like button, follow us for more behind the scenes from the world of manufacturing. Subscribe, because the future of the things that you are doing is going to be amazing.